One more reference type that I want to cover in more depth is the array. The array is a simple data structure to manage a collection of multiple objects or multiple values. And the array itself is always a reference type. Now you might remember that in our gradebook, we are managing a collection of multiple floating point values. Those values represent the grades in the gradebook, but we are using a list to store those grades in the gradebook, not an array, primarily because arrays have a fixed size. That means when I create an array, I have to specify the size of the array, which is how many items the array can hold. And that size, although you can change it, changing the size of an array can be a relatively expensive operation. In our program, if we knew exactly how many grades we might need to store, or at least the maximum number of grades, then it might make sense to use an array instead of a list. But since we don't know how many grades someone might want to store, we use a list, because a list will just grow automatically and grab the space needed to keep storing new items every time we call add on that list. But one thing both the list and the array have in common is that they are both zero indexed, meaning the first item in a list or an array is at index 0, which is sometimes confusing because we tend to think of the first item being in position 1, but in C# and many other languages actually, the first item is position 0. You might remember we encountered this indexing already when we worked with the args array passed to our program in the first module. The args array contained the command line parameters, and the first parameter to the program was in position 0. Here in this code snippet, we see the syntax for declaring an array. First is a const int variable. The const keyword is something that you can add to a variable if that variable is going to hold a constant value. Once I've declared and initialized the variable, the value of that variable cannot be changed. And in this code, we will store the final score for 4 students. So the syntax for declaring an array is to use the type that the array is going to hold, followed by square brackets. What we're declaring here is an array called scores. It's going to hold integers. We will construct a new array that can hold exactly 4 integers. And this is all strongly typed, so if I try to assign a string or a floating point number into one of the positions of the array, I would get a compiler error. The array can only store integer values. And then we have a for each loop, very similar to the for each loop that we have inside of the gradebook when we're computing statistics. It's going to look at each integer value in that array of scores and add that score to another variable where we're keeping track of the total score. Let's work with arrays a bit inside of our unit tests. Inside of our test project, let me set you up with a test method that you can use to start experimenting with arrays. So let's just call this test using arrays. And I'll need to declare an array. So let's create an array of floating point numbers. That means I need to use the float keyword. And then I need to use the square brackets. That tells the C# compiler this is an array. Let's just call the array grades. And now, instead of initializing that variable immediately, let me just declare the variable, because right now I have a variable that can point to any array of floating point numbers. It doesn't matter what the size is. In order to effectively use that variable, however, I will need to point it to a specific array. So let's assign a reference to a new floating point array. This time when I use the square brackets, I need to specify the size of that array. Let's give the array the ability to store 3 numbers. And then let's call a method that will add grades into that array. So a method that doesn't exist yet, it will be called add grades, and I'll pass in the grades. And then I'll want to write an assertion. I'll want to assert, let's say, that the value 89.1 is in array index sub1. So we need to create this method add grades, and let me show you a trick. Visual Studio is smart enough that if you've written a method that doesn't exist yet, Visual Studio has the ability to create that method for you. It doesn't know how you want to implement that method, but if I go to the light bulb and select generate the method, I now have a private void method called add grades that takes as a parameter a reference to an array of floating point numbers. The code that is inside this method right now, I want to remove that. And I want to be able to say that grades sub1 equals 89.1, the floating point number. Again, you do have to be very careful when comparing numbers for strict equality. That will always work for integers, but for floating point numbers, you can sometimes run into trouble, as we saw earlier. But you might be wondering, since float is a value type, will the calling method using arrays actually see this value placed into the array? And the answer is yes, because an array is a reference type. And even though I'm dealing with a value type, which is a floating point number, That number is stored inside the array, and both the grades variable inside of using arrays and the grades variable that is the parameter to add grades, those are both references to the exact same array. If I run the test with Control RA, I will see that that is a passing test. And let's recreate a scenario that we were looking at earlier. What happens here on the first line of code if I say grades equals a new array of floating point number, let's say of size 5. What happens when I run the test now? Well, the test will fail because now I've created a new array. I've placed this value inside of that new array. The grades variable that is inside of using arrays, that's still pointing to the original array of floating point numbers that we had. And this method add grades no longer uses that. This is not placing the value into the array that we need. So let me remove that line of code, rerun the test, leave you with all passing tests. And now I encourage you to experiment with the code that is inside of this unit test project. Try some different scenarios, passing around value types and reference types, and using arrays and using strings. And with every little bit of code that you write, you'll become more comfortable with the C# language.